ಇದು height வேணும். எதுவும் இல்லையா? இன்னும் கொஞ்சம் ஹைட் வேணும். Shall we get started?
Yes, sir.
What was the last concept we saw? This moment of inertia based problems. No? So we'll do some more problems and then go to the last part of this chapter. Okay, we'll complete this chapter by today. So yesterday you guys attended online, no? I'm not sure how much is the understanding level. Let's see. Okay, so we'll get started. Right. So four particles each of four particles of masses 4 kilogram, 2 kilogram, 3 kilogram, and 5 are respectively located at the four corners ABCD of a square of 1 meter as shown. Calculate the moment of inertia of the system above. An axis passing through the point of intersection of the diagonals and perpendicular to the plane of the square. Second, through the side AB, and third, through the diagonal B. It's a good problem. So before you start, right, I have three questions I want you all to answer. When you take a point mass into consideration, what is going to be the moment of inertia? Due to a point mass, what is going to be the moment of inertia when it is placed at a distance r? M into r square, right? When you talk about an extended object, it is integral of dm r square, where dm is the small mass that you consider. We saw the derivation of this. Next. What is parallel axis theorem? When we want to find the moment of inertia about any axis, which is parallel to an axis passing through the center of mass, then the moment of inertia is given as the sum of the moment of inertia to the center of mass plus mass of the object into what square? Distance between whom? Distance between the two axes square, right? Thirdly, what is perpendicular axis theorem? When you have a two-dimensional object, that is a lamina, then what will happen? Then a lamina is transferred. Yesterday is just on the point and told you what the mistake was. Only one word spoke. They gathered an answer, saying that it was wrong. What is the statement? So when you have a two-dimensional shape, only then you can apply perpendicular axis theorem. So when you have a two-dimensional shape, if you need to find the moment of inertia about an axis which is perpendicular to the plane, that will be equal to sum of moments of inertia of two other axes, like in the plane, not in the same plane, in the plane of the shape. And how are those two axes supposed to be? They should be perpendicular, and they should be mutually perpendicular to the axis to which you are trying to find the moment of inertia. So that is why we got the statement as I z is equal to I xx plus I y. Okay, the reason why I asked this, if you read this question, as soon as you see a question, you will be able to understand what theorem you are supposed to apply. So there are only three concepts, okay, how to think of the part. First question you need to answer them. Wherever problems are based on moment of inertia, you need to start observing. Are they talking about point mass or extended mass? If it is about point mass, then you can apply the formula mr square. If it is about extended mass, integration is to be done. Here, 4 particles. So first keyword is telling me that I need to deal with point mass. I need not worry about integration. So 4 particles of mass, 4, 2, 3 and 5 kilogram are based at 4 corners of the square, and the square side is 1 meter. Now, whenever they ask you the moment of inertia of the system, they should give you the axis about which they are asking. So depending on the axis, you can decide which theorem you are supposed to apply, or you won't need the theorem. If you see the first part of the question, calculate the moment of inertia of the system about the axis passing into the point of intersection of the diagonals and perpendicular to the plane of the square. This is the square. If I think of an axis like this, then I need to calculate the moment of inertia about that axis. So with respect to my thinker, what is going to be the perpendicular distances? They will be exactly half of the length of the diagonals. So for me to calculate the first parameter, it clearly tells me that I don't need to go with any theorems, because by default they are asking who the center of gravity. Actually, it is not center of gravity, center of the shape, right? Symmetric geometric center, right? So for the first part, how do I calculate? The job is very simple. Moment of inertia is a scalar quantity. So moment of inertia for A is going to be equal to how much? 4 into how much is the distance? What is the length of a diagonal? 0.21. Clear? If the side of the square is A, what is the length of the diagonal? A root or root 12, both are same. So half of it is going to be A by a root. Correct? So it will be 4 into 1 by root 2 the whole square. I am not writing the formula. So 4 into 1 by root 2 the whole square. I hope people who are online are able to see. Just give me a confirmation.
Yes, sir.
So 4 into this distance square. What is the moment of inertia of the mass which is placed at P? 2 into 1 by root 2 square. IC 5 into 1 by root 2 square. Sorry, 3 into 1 by root 2 square. ID 5 into 1 by root 2 square. So what is going to be the answer? Here it is going to be 2. Here it is going to be 1. Here it is going to be 3 by 2. And here it is going to be 5 by 2. So what is going to be the moment of inertia? It is a scalar quantity. So add them. So moment of inertia can't be negative. So just add them. You're going to be 2 plus 1, 3, 3 plus 3 by 2 is. So 3 by 2 plus 5 by 2 is going to be 4. So 4 plus 3 is going to give you 7. And look at the unit, kilogram meter square. So had it been in centimeter, you should write it as kilogram centimeters. Okay. Now, you need to find the moment of inertia about the side AB. So, in this revolving like this, if the square comes to goes to the other side, if it is revolving in this way, then you need to find the moment of inertia about AB. How do I do that? For that, I need to know what is the moment of inertia to any of the axes. What theorem should I apply? Can I apply perpendicular axis theorem? Can I? So I know the moment of inertia about this axis. So first one that they asked is an axis which is perpendicular to the plane. So can I call this as IZZ? So anything perpendicular to the plane, I'll take it as ZZ or ZZ dash. Okay. Now this diagonal and this diagonal are perpendicular to each other. So can I say IZZ is equal to how much? Or I'll make it simple. That's not complicated. I'll make it simple for you. See, when this is going to be the axis of rotation, right? When this is going to be the axis of rotation, this 5 kilogram mass is at a distance of how much value? 1 meter. So moment of inertia of D for the second one, moment of inertia of D about AB is going to be 5 into 1 square, that is 5. Moment of inertia of C about AB is going to be 3 into 1 square, that is going to be 3. So these two masses are revolving about this. So any object that is passing through the axis of rotation itself will not contribute to the moment of inertia because there is no distance. So what is going to be the answer? Moment of inertia about AB is going to be 8 kilogram meter square because it is because of this mass and this mass. Using the same logic, find out what would be the moment of inertia about BD. So when you talk about BD, what are the two masses which will not contribute to the moment of inertia? Which will not contribute? 2 and 5 are lost. So with respect to BD, this distance is how much? 1 by root 2. This distance is 1 by root 2. So 4 into 1 by root 2 square plus 3 into 1 by root 2. How much is going to be the answer? 4 into 1 by root 2 square is 2. 3 into 1 by root 2 square is 3 by 2. So 2 plus 3 by 2 is going to give you 7 by 2. So the moment of inertia about this axis BD is going to be 7 by 2. That's the answer. Or 3.5. Is it clear? So here I didn't want to take the perpendicular axis theorem because the masses are not equal. Had they been equal, I would have used that one. I would have gone with it. Is the point clear? Are you able to think? Next time, if a question comes, you can think, no? Shall I proceed? So this is grams centimeter square. The moment of inertia of a uniform circular disc about its diameter is how much? 100 gram centimeter square. 100 gram centimeter square. What is the moment of inertia about its tangent? What theorem will you apply? Parallel axis, because you know the moment of inertia through the center of mass. Wherever center of mass comes, parallel axis. So what is the moment of inertia about the center of mass? 100, that is given. But what is not given here? You don't know the mass, you don't know the value of R. Now we need to start thinking. For at this, what is the moment of inertia about the diameter? mr square by mr square by Check it. Yesterday we solved this problem. Sigma square by the circular distance.
M square by 2.
Sigma square by
2, sir.
because moment of inertia of a disk about this axis, about an axis perpendicular to the plane and passing through the center of gravity is mr square by 2. So when it comes to the diameter, what will you apply? This is xx and this is yy dash. And zz dash is perpendicular to the plane. So I z z dash is equal to I x dash plus I y dash. I x dash and I y dash are the same. So can I write it as 2y? And what is the moment of inertia about z? With mr square by 2. So on the I in now, with mr square by 2. Is that clear? So it is mr square by 4, and you need to write that because mr square by 4 is 100. Now mr square ever. Obviously, it is going to be 400. Right? Now, observe the question again. There is a uniform circular disk for which you know the moment of inertia about one of the diameters. Right? How much is the value? 100. And what is the moment of inertia about the tangent? So I about tangent is equal to, when I apply parallel axis theorem, can I write it as ICM plus mass of the object into what is the distance between those two axes? R. So M into R square. So ICM ever 100. MR square ever. How much is the answer? 500 gram centimeter. Puridam. The second part is slightly ambiguous. I think there is a mistake in the question. About an axis perpendicular to the plane, it can be anywhere. If I'm not wrong, they are expecting tangential to the surface and perpendicular to the plane. What will be the answer? Meaning, if this is going to be the disk, this is diameter. This is this is the disk. This is the diameter. This is the axis perpendicular to the center of gravity. This is the axis which is tangential and perpendicular to the. So if they're asking about this axis, moment of inertia about this axis will be equal to moment of inertia through the center of gravity plus m into r square. Again, you need to apply parallel axis theorem. The only difference is the diagram is going to look like this. Are you able to understand this point? So if I call this as PP dash, so moment of inertia about PP dash is equal to the moment of inertia about center of mass plus mr square. So what is going to be the moment of inertia to the center of mass in this case? It is mr square by 2. Correct, Ada? Plus mr square. Up and 3 by 2 mr square. 3 by 2 into. But what did we find the value of mr square as? 400. Substitute the 400 here. You are going to get the answer as 600 grams centimeters. Is it clear? See, the only challenge is with respect to this chapter, active of. If you're able to find that, you can solve any problem. Okay. See, So here you have slight calculations. So what is the moment of inertia of a cylinder above its axis? So when they give you just cylinder, it is understood that it is a solid cylinder. So for solid cylinder, what is the moment of inertia? You can remember it is the same as that of this. So for solid cylinder about its axis and for the disk about its axis, the value is mr square by 2. Whereas for a hollow cylinder and for a ring, this is mr square. Remember it like that. Okay. So if you see, this problem is actually simple only. It is only one step. So moment of inertia is going to be mr square by 2. But what is not given is mass is not given. So how do you find mass? Mass is equal to density into volume. So density is given as 8 into 10 power 3. The volume of a cylinder is going to be pi r square h or pi r square L. So 8 into 10 power 3 into 22 by 7 into R is 0.05. So can I write it as 5 by 100? That is going to be 25 divided by 10 power 2 into length order 15 by 10 R. So as far as possible, eliminate the denominators and convert to fractions. So 10 power 3 will cancel this. What I left out with 25 into 15 is 375. So 22 into 8 is 176. So 176 into 375 divided by 100. Okay, no other option. You have to multiply 3 digits into 3 digits and divide it with 100. 100 less 700. 700. 700. Okay. Into R square. So let's not waste time on calculation. Not surface areas and volumes of your tensor. So we'll concentrate more on contact. Okay, this calculation you do later. So this is the value of M. Take this and substitute it here. R square, find it out. Right? Can I proceed? I don't want these numbers. All these are simple. Okay. So let's do some problems that are based on radius of variation. You remember what is the radius of variation? It is that distance from the axis of rotation where you replace the whole mass with a point mass so that the moment of inertia of that point mass is same as that of the whole object. Definition is complicated. Put it in simple terms. If you know the moment of inertia of any object about any axis, write the moment of inertia of whatever it is. Write the moment of inertia of that object about the axis they asked for and equate it to mk square. M and M will get cancelled. This k is what is called as radius of variation. Okay. Calculate the ratio of radius of variation of a circular ring and a disk of same radius above the axis passing through their center and perpendicular to their planes. I am assuming that mass is also same. Okay, that is not given, but I need to take it. What is the answer? So for a ring, what is the moment of inertia about an axis passing through the center? Just now I told you, mr square. That mr square should be equated to mk square. K and M and M will get cancelled. K will be R. Similarly, if I take a disk, mr square will be equal. Mr square by 2 will be equal to mk square. M and M will get cancelled. So K will be equal to R by 2. So what is the ratio? R divided by R by 1. Cancel this. Answer is equals to. Here. Here. Solve this. Find the radius of gyration and the moment of inertia of a rod of mass 100 gram and length 100 centimeter, that is 1 meter, about an axis passing through its center and perpendicular to its. So, what is the moment of inertia of a thin rod that is passing about an axis passing through the center of it? ml square by ml square by 12. ml is given, L is given. So ml square variable should be equal to whom? Large radius of gyration. Take the ml square equal to mk square, m and n get cancel. K will be root and minus L divided by ml square is mk square. Don't put the pendant in the ml square by 12 is equal to mk square. What you get cancel? Constant. M and n is gone. What is the value of k? L by sorry. Yeah, L by root 12. So root 12 is going to be 2 root 3. Right? So L divided by root 12, L is already known 100. And you already the substitute, you are going to get the radius of gyration. That's it. So K is equal to L by root 12. L is 100 into 10 power minus 2 divided by 12. Here. Done. So what is the value of moment of inertia you got when you calculate it? Okay, the calculation you go later. Next is a problem that is based on kinetic energy and moment of inertia. What is the relationship? That was the last derivation we saw today. Rotational kinetic energy is equal to half. It's very simple. Okay. What is the basic formula for kinetic energy? Half mp square, right? So mass is the measure of inertia. I is the measure of moment of inertia. So in linear system you have mass. In rotational system replace it with moment of inertia. In linear system, if you have linear velocity, rotational system deviates into the so much will it be? Half I omega square. So apply that half I omega square. They have given you 1000 RPM. So frequency is 1000 RPM. And its kinetic energy is 10 power 6. So kinetic energy is equal to 10 power 6 joule. So kinetic energy is equal to half I. I is what we need to find. Omega square. Omega square is 2 pi into F square. So 10 power 6 is equal to half into I into 4 pi square into 10 power 6. So this and this we get cancelled. Here will be 2. So I will be equal to 1 divided by 2 pi square. So RPM, okay, divided by 60, I can see that. Divided with RPM, divided by 60, sorry, by 60. So it is going to be 60 square. So we hope you understood the problems. So the last set of problems we have, the last concept that we have is rotation. Okay. Sorry, not rotation, rolling. One minute. So write down the next heading here. The rolling motion. So before this, I want you to make a note of all these points. Force is equal to mass into acceleration. Torque will be equal to I into R. Because mass should be replaced with moment of inertia, A should be replaced with R. Okay. Kinetic energy is half mv square. And rotational kinetic, so translational kinetic energy is half mv square. Rotational kinetic energy is half I omega square. Is that point clear? So now we need to discuss what is this rolling motion. And when I talk about rolling motion, here we are going to discuss about the concept of pure rolling. I'll tell you what it means. Okay. See, suppose there is a wheel, okay, which is moving like this. It is moving, right? If suppose this object, it's like a disc. Ignore the shape and thickness. If it is made to rotate like this, it is rotating about an axis. So this kind of a motion is called as rotation. What is it called? It's called rotation, right? Or revolution. If this is there and it is moving like this, it is called translation. What is it? It's called translation. But here we are neither discussing about rotation nor translation. It's completely a new term. What is it? It's rolling motion. So the meaning of this rolling motion is, if the object is having rotational motion plus translation motion, then you call that as rolling motion. So the simplest definition that you can give is rotational plus translation. So rotational plus translational motion is called as rolling motion. This is a point here. Am I clear? Okay. Whenever I speak about rotation motion, I need to define the axis of rotation. Whenever I'm trying to talk about the translational motion, I need to define the center of gravity and find what is the acceleration of the center of. So these are the two important points I need to have in my mind for me to understand what is rolling motion. But here when we see, by default, in your syllabus, they give rolling motion, but they are really talking about pure rolling motion. So let's understand what is the meaning of this. If an object is revolving and having a translation in such a way that when it is revolving on a ground, when it is rotating on a ground, each object on top of this rotating object is coming in contact with the ground at some instant. Right? For example, this is there. If I start from here, this end is exactly the opposite end diametrically. It is a diametrically opposite end. So when will this point come in contact with my hand? After completing half a revolution, means after it has traveled a distance of pi r, half of the circumference. After 2 pi r, what will happen? The point that started will again come back in touch with my hand after traveling a distance, a linear distance of 2 pi r, right? So when each point is coming in contact with the surface, that value should be uniform in the sense. The amount of time each point is trying to come in contact with the surface should be a constant value. Means one point can't be in touch with the surface for 1 second and the other point can't be in contact with the surface for 2 seconds. When will that happen? When rolling is there and sometimes it is skidding, again rolling and skidding. That should not happen. It should be in a continuous revolution and translation. If that kind of motion is able to be achieved, you call it as pure rolling motion. When will you call it as pure rolling motion? When there is no slipping of object taking place. I told you about skidding, right? But skidding in physics is called as slipping. So when the object is not slipping during the translation motion and it has continuous rotation and translation, then you call that kind of a motion as pure rolling motion. Is that clear? Now our job is to derive expressions for accelerations. Right? When I say acceleration, I'm talking about linear and angular, right? Along with that, I need to find the velocity with which an object is traveling at a particular instant. All these things to be kept in our mind. For which I will consider an inclined plane. Okay. On which, let's say, there is an object which is rolling down. It is rolling and coming down. It is not slipping. So when I say rolling, the center of mass has some acceleration associated with it. Am I right? And it is revolving about an axis passing through the center of gravity and perpendicular to the axis. So if you are able to find the moment of inertia of about that, we will be able to define the kinetic energy also. Right? And let me say the height is going to be h. height of the inclination is which I'm not concerned about what is the horizontal distance or the length. As of now, I'm not concerned based on plot. Okay. Can you try to describe the physics behind it? What is going to happen? Observe, you tell me what are all the concepts that are coming to your mind. One thing you're able to see is the object is traveling naturally. Like I have to speak in terms of chemistry, spontaneous. Because of whom? Because of gravity. We are not applying any force. Gravity is pulling it down. Right? So when that is going to be the scenario, right? Think this. Had there been only gravity acting on the system, what would have happened is G will be like this, G cos theta will be like this, and G sin theta will be like this. Am I right? Now, what would have happened? The G sin theta would have dragged the object to have only translating motion. Then you cannot discuss the concept of rolling it. Then, which other force is responsible for this object to roll? That is, who is adding value to the rotation motion? Now, I'll club all the concepts and give you a thought process. Listen to this. Why I told d sin theta can't put this object in rotation is because d sin theta is passing through the axis above which it is revolving. And when I discuss the concept of torque, what did I tell you? Any force that is passing through the axis of rotation can never contribute to the torque. When there is no torque, there is no rotation. So if there is no rotation, there is no concept of rolling. Means I need some other force which is actually causing this rolling to take place, and that force is going to be, observe, the frictional force. So this frictional force is the one which is actually putting the object into rotation. Why is it? Actually, I'm holding it. Okay. If I release this, what do you think will happen? Observe it. What happened? Only once demonstration. What happened? Did you see? Did it fall down directly or did it roll and come? You saw it rolling. Alternatively, it went slowly. You saw it rolling. Why did that happen? Because when this part is there, the rope was tangential to the surface. So there is tension acting in this direction. And gravity was acting through the center of gravity, right? This tension put this object into rotation. So actually from this side, you would have seen, you would have seen that the object was actually revolving like this. So which direction is this? Clockwise. So when there is a force acting upwards, it creates a clockwise torque. Is it right? Observe. Is it right? I'll not say clockwise torque, clockwise rotation. Torque is not in clockwise direction. So in which direction is it that? So when the force is upwards, tension was upward, it was rotating clockwise. In a similar way, when the friction is like this, in which direction will it revolve? It will revolve clockwise. That is the angular velocity. Okay. This is very clear only. Those who are online are able to understand. Slipped off, huh?
Yes, sir.
What slipped up?
No, sir. Understood, sir.
This distance is R. Okay. So this friction is the one which is responsible for the torque. So I wrote 4 equations. You have those 4 equations. Can I write torque is equal to I alpha? So what is the value of torque? Force multiplied with perpendicular distance. Can I write this to be equal to? See, I will not write the moment of inertia as m r square. Rather, I will write it as mk square. Because if I replace this object with any circular object that I want, I can substitute the value of k. Or else what will happen is you need to derive the same formula for ring separating, disk separating, sphere separating, be a tedious process. So one common formula is this. That is the reason why this radius of gyration concept actually. Because I told you, no, the left hand side, what did you do when you calculated? You write the moment of inertia of anything you want. Right hand side is always a common, right? So if you know the radius of gyration of that particular object about the axis, you can just keep plugging in the value. So mk square into, remember this, A is equal to R alpha. You know this, right? From circular, A is equal to R alpha. So alpha will be equal to A by alpha. So can I write it as alpha is equal to A by alpha? Here. So what will be the value of frictional force? It will be mk square into A divided by R square. Can I write this as equation number 1? Can I? Mk square into A divided by R square. This is from the rotation motion. Now what I do is I write the value from the translation motion. So I'm able to understand that there is an acceleration in the downward direction. So what forces, what is the net force that is acting on it for that acceleration to get generated? It is mg sin theta minus F, that will be equal to m into AC, or I'll write it as A. Can I? Which implies mg sin theta minus, what is the value of F? It is mk square into A divided by R square is equal to ma. So what gets cancelled? F is lost. This I can take it to the other side. So g sin theta will be equal to 1 plus k square divided by R square into A. So what is going to be the acceleration? A will be equal to g sin theta divided by 1 plus k square divided by R square. So this is going to be the acceleration of any object, which is going to have a rolling motion. That's the point here. So make a note of this. So this value is to be remembered. G sin theta divided by 1 plus k square divided by R square. Okay, this value is to be remembered. This is about the acceleration of the object. The next question is about the velocity with which it is going to reach the point. Okay. How do I calculate the velocity? It's very simple. So can I say that the potential energy that the object is having is getting converted to rotational kinetic energy and translational kinetic energy. Because the object is revolving and translating. So can I say that potential energy of the object is equal to rotational kinetic energy plus translational kinetic energy? What did I apply? There was a good talk that what did I apply? Energy conservation, but where is energy conservation given? But you have friction in this, and how did I apply? Because friction is not dissipating anything. Here, what is it doing? Friction is the one which is responsible for the object immediate rotation. It is not letting the object slip. Clear? Because had the object started slipping, then there would have been contact between them, which would have actually got converted to heat energy. Here there is no loss of energy taking place. Clear? Not every time friction is going to be opposite. Suppose. But yeah, so that is like doubling the heat. I was actually waiting for that question. Good that you asked. So potential energy of the object is going to be mg into h is equal to rotational kinetic energy is half I omega square. Instead of I, can I write mk square so that I want to stick one step? And what is omega? V by r the whole square plus translational kinetic energy is half mv square. So what gets cancelled? M is lost. What is our job? To find the value of V. So GH will be equal to V square. I'll take the 2 to the other side. V square into 1 plus K square divided by R square, which implies V is equal to tau 2GH divided by 1 plus K square divided by R square. And this particular derivation is given in your textbook at the very end of this. It's very, very, very important. Mark it as important. If at all they are asking any derivation from this chapter, this will be one of them. This might be. Okay. So V is equal to root 2 GH divided by 1 plus K square divided by based on this, we are ready to solve the problem. Even this, the chapter is over. Okay. We have some more time. We'll do some problems based. Solve this. Energy of 484 joule is spent in increasing the speed of a flywheel from 60 rpm to 360 rpm. Find the moment of inertia. So simple. Energy spent is converted to what? Is equal to the change in kinetic energy, which I'm talking is rotational kinetic energy. So what is the energy spent here? 484 is equal to, what is the change in kinetic energy? I is common, omega final square minus omega initial square. So half into I into omega final, can I write it as 2 pi or 4 pi square into F final square minus F initial square? I didn't convert one. I didn't do any conversion. Not yet done anything. Just writing the formula. So this is going to be 484. So 484 into 2. Okay. Is equal to I into 4 pi square into F final is how much? 360 by 60. That is 6 square minus F initial is 60 by 60. That is 1 square. So 121. So it is going to be 242 into 49 divided by 484 is equal to I into 6 square minus 1 square is 35. Am I right? So observe what is going to happen. 242 will cancel this 2 times. So I will be equal to 49 divided by 70. How much is that? 7 by 10. It is going to be 0.7 kilogram weightage. Did you understand? Okay. A uniform circular disc of mass m is set rolling on a smooth horizontal table with a uniform velocity v. Find the total kinetic energy of the disc. So here, why are they using the word total kinetic energy? Because whenever an object is rolling, what energies are associated with it? So total kinetic energy is going to be rotational kinetic energy plus translational kinetic energy. What is going to be the rotational kinetic energy? It is going to be half I omega square plus translational is going to be half mv square. Half into I is how much? It's a circular distance. So it is going to be mr square by 2 into omega square b square divided by r square plus half into m into b square. R square and r square are lost. So mv square by 2 plus mv square by 2 is going to be equal to how much? 3 mv square by 2. So 3 by 4 of mv square is going to be the answer. Do this. 2 minutes time, do it fast. What is the answer? The moment when you find the rotation kinetic energy based on the rotation to its kinetic total energy. So rotation kinetic energy is how much? Half I omega square. Half into I is 2 by pi mr square omega square. So 2 and 2 will get cancelled. So it is mr square omega square by 5. What is the translational kinetic energy? Half m v square. Half into m into r square omega square, because v is equal to r omega. Right? So total kinetic energy is, total energy is how much? 7 mr square omega square divided by 10. So they are asking the ratio of the rotational, that is mr square omega square by 5 divided by 7 mr square omega square divided by 10. So mr square omega square and mr square omega square will get cancelled. Answer will be 2 by 7. So out of 100%, partial percent is going to rotation and remaining going to the translation. Yeah, I forgot one concept, that is conservation of angular momentum. So write down the heading as conservation of angular momentum. Okay. Project is very simple. This one. What is conservation of linear momentum? When external is acting on a system is equal to 0, then the initial linear momentum is equal to the final linear momentum. So if it comes to the concept of conservation of angular momentum, what should you say? When net torque is 0, the initial angular momentum is said to be equal to the final angular momentum. Write it down. When net torque is equal to 0, initial angular momentum is equal to the final angular momentum. That's it. You have to understand. That's it. So how do you write it mathematically? For linear, how do you write it? M1 V1 will be equal to M2 V2. So M is supposed to be replaced with I. So I1 omega 1 will be I2 omega. Okay. This is the mathematical expression for conservation of angular momentum. Yeah. So I1 omega 1 will be equal to I2. So that's okay. So is there any other concept that you have it out with? Let me see if there are good formulas. Try this one. Example 14. A solid cylinder rolls down an inclined plane. Its mass is 2 kg and radius is 0.1 meter. If height of the inclined plane is 4 meter, what is the rotation kinetic energy when it reaches the foot of the plane? So I just gave you a formula, right? When it reaches the bottom, what formula did I give you? I gave you the formula for velocity. How much is it? 2gh divided by 1 plus k square divided by r square. Right? So they are asking what is the rotational kinetic energy when it reaches the top unit. So they are not asking the velocity, they are asking the kinetic. What kinetic energy? That too not invocal kinetic energy. They are asking me the rotational kinetic energy. Rotational kinetic energy at that point will be how much? Half I omega square. Where the base of omega is right, e square by r square, where v is the velocity at that point. Can you do that? Right? Right? The rotational kinetic energy at bottom will be equal to half I omega square or half into mr square by 2 into omega square is v square by r square and r square of common. So 1 by 4 m into what is the value of v? Root 2 gh by 1 plus k square divided by r square. Am I right? But I didn't put the square root here because we have v square. So this will cancel by this. Mass is given 2 divided by 2 into g, I take it as 10, h is 4 by 1 plus. What is the radius of the equation of a solid sphere cylinder? Radius of gyration will be r by root 2. So k square will be r by 2. Sorry, r square by 2. R square by 2 by r square and r square are 1. So what will we get? 2 and 2 are 1. 40 divided by 2, which will give me 20. 20. So rotational kinetic energy also has the same unit, 20 J. Here. So we'll do one last topic. First, we copy this. Did you all copy? Any doubt? Shall I proceed? Now do this problem. Wheel of mass 5 kilogram and radius 0.4 meter is rolling on a road without sliding. Means it is in pure rotation, pure rolling. Rolling without sliding with angular velocity of 10 radians per second. The moment of inertia of the wheel about the axis of rotation is 0.65 kilogram meter square. What percentage of the kinetic energy of rotation is the total kinetic energy? What is the percentage of rotational kinetic energy in the total kinetic energy? So how much is it? So for a wheel, you take it as it is. Here, some problem, right? The wheel will consider the ring depending on how it is. This problem I will take. Whatever it is, approach is more important. Actually, problem they should mention to be we consider a ring or it is. Here it is not. What is the answer? How did you do? So half I omega square is the kinetic energy of the rotation divided by half I omega square plus half mv square. Half is gone. So I is mk square. If I take it to be this, then it is going to be mr square by 2 into v square divided by r square. The whole divided by mr square by 2 into v square by r square plus mv square. M will get cancelled. R square is gone. R square is gone. So v square by 2 by ct square by 2 cancel. It's going to be 1 is to 3. How much is it? 23%. So out of 100% of the total energy, 33% is taken by the rotation energy. So fraction is 1/3. Total is into 100, 33. Am I clear? Actually, I'm sorry. In this problem, they didn't give you this for wheel because they've given you the moment of motion. They've already given it 0.6. But generally, in a problem, they are supposed to give you. Freedom. Or else you will not know whether you should take it as mr square by 2 or mr. Had it been a ring, had it been a ring, the answer would have been 1 is to 50% would have been for rotation. System of particles and rotation motion. On minute. So any other doubt? Any other concept that is not clear? So next class can you start gravitation? Okay, you all go through the schedule that was. Right, to know when there is accordingly as the schedule goes to be.
Sir? Sir, I have a doubt, sir. Sir, what is the moment of inertia of a disk, sir?
mr square by 2.
Sir, then why do we have mr square by 4, sir?
Where did they write 4?
For the previous sum, somewhere we wrote mr square by 4. I think it's about its diameter.
Whenever you ask a question, you should ask me moment of inertia about which axis. By default, if you ask me, I will say only about the axis through the center.
So if it's through the diameter, above the diameter, then it's mr square by 4, sir.
Yes, because the diameter is mr.
Okay, sir.